Exercise 13. AB is a given segment. We have a dilation of center A and ratio 1/3 and a translation with vector AB. We need to identify T round H. You know that the composite of a translation and a dilation is a dilation with the same ratio 1/3, but the center is distinct from A. So we say T round H is a dilation of center omega and ratio 1/3. So T round H is translation with vector AB round dilation of center A and ratio 1/3. So we get a dilation of center omega and 1/3. To know the place of omega, so I take a counter example. So I take T round H of A. I started with A because A is invariant by H. So T round H equal translation H of A. H of A, because A is invariant, so it is equal, translation of A equal B. By definition, translation of A equal B. So T round H of A is B. Means omega B, since omega is the center, equal 1/3 omega A cross multiplication, omega A equal 3 omega B. Both of them are unknowns. So here I introduce B to the left side. Omega B plus BA equal 3 omega B means BA equal to omega B means omega B equal half BA. Omega B half BA. Pay attention. Omega B and BA have the same sense. So omega B will be here, not the midpoint. So omega B equal half BA. Now part out, we are going to find H round T. Also H round T is a dilation H prime of center I and the same ratio 1/3. To know the place of I on AB, we say H round T of A. Now, it will be H translation of A. Translation of A is B. We get H of B equal B prime. H of B equals B prime. It means that AB prime equal 1/3 AB. AB prime equal 1/3 of AB. AB prime equal 1/3 of AB. AB prime equal AB/3. They have the same sense. And the length of AB prime equal to the length of AB/3. Now to know the place of I, H round T of A equal B prime. It means that IB prime, since I is the center, equal 1/3 IA. So IA equal 3IB prime. IA equal 3IB prime. Both of them are unknowns. Then I put B prime here IB prime plus B prime A equal 3IB prime. It means that IB prime equal half B prime A. IB prime equal half B prime A. In I, B prime equal half B prime A. Pay attention, they have the, so IB prime will have the same sense as B prime A. Now we start with exercise 14. Exercise 14. Also, it is the composite of two dilations. CD is a segment. Consider the two homothéses. The first homothésis is of center C ratio -2. And the second homothésis is a dilation of center D and ratio 1/3. Part 1, determine the nature of H2 round H1. Determine the nature of H2 round H1. The composite of two dilations is a dilation. So I call this dilation H with center omega, and ratio is the product, not the sum, the product, -2 times 1/3. So H2 round H1 is a dilation of center omega and ratio -2 times 1/3. So I call it here in this H2 round H1 is a dilation of center I and ratio -2 times 1/3. It is equal a dilation of center I and ratio -2/3. Only it is required here to determine the nature, not the elements. Now, determine H2 round H1 of C, then we need to construct the center of H2 round H1. Determine H2 round H1 of C, then construct the center. We call this center I. Now, H2 round H1 of C equal H2 into H1 of C. H1 of C, H1 عنده center C, so C is invariant by H1. So H2 of C, let's call H2 of C equals C prime. Since H2 of C equals C prime, and C prime and H2 and the center D and ratio 1/3 means DC prime equals 1/3 DC. DC prime equal 1/3 DC. Pay attention, they have, it is not on this side. The C prime is C prime, DC prime have the same sense as DC. DC prime equals 1/3 of DC. Now to construct the center I, since H2 round H1 of C equals C prime, H2 round H1 of C equals C prime, then IC prime equal -2/3 IC. Since I is the center and the ratio is -2/3, then IC prime equal -2/3 IC. cross multiplication is 3IC prime equal minus 2IC, since both of them contains I, and I is unknown. So here I decompose, either I decompose IC prime or I decompose IC. To decompose IC prime, I can put it 3. IC prime is IC plus CC prime equal minus 2IC, then expand 3IC plus 3CC prime equal minus 2IC, then 3CC prime equal 5IC equal 3CC prime. It will be equal minus 5IC, this one. So IC equals minus 3 over 5 CC prime. IC equal minus 3 over 5 CC prime. يعني هيدا الاي بده يكون بهيدا البليس هون. هيدا الاي هون. So here it is not correct. It is not correct, the position of I. Now we go to exercise 15. Exercise 15. Determine the complex form of a translation F in each of the following cases. We have 3 types of complex transformations. We have the translation. So translation Z prime equal Z plus B, where B is the affix. B بيكون هو Z للV. هذا translation. In case of a rotation, Z prime equals Z plus B, تكون AZ plus B. A is equal e to the I alpha, where alpha is the angle of rotation, and Z of the center omega is equals B over 1 minus A. And in case of a dilation, in case of H, dilation, Z prime equal KZ plus B. So first part, exercise 15, we have a translation. F is a translation with vector V and fx minus 2 plus 3i. So F is a translation. Z prime equals Z plus B. So Z prime equals Z. B is minus 2 plus 3i. It is simple. Now, F, a dilation with center O and ratio minus half. Since it is a dilation of center O, بتكون Z prime equal KZ only. Z prime equal KZ. So Z prime equals minus half Z. Part 3, F is a dilation of center omega of fx2 minus 2i and ratio 3/4. So I put z prime equal kz plus b. So z prime, since k is 3/4, 3/4 z plus b. To find b, I can say z omega equals b over 1 minus a. The omega and the center 2 minus 5i. So I put 2 minus 5i equals b over 1 minus k, or a. 1 minus 3/4 is 1/4. Then b equal 2/4 by cross multiplication minus 5/4i. So z prime equals 3/4z plus 2/4 minus 5/4i. Part 4. F is a rotation of center omega of fx minus 3 plus I and angle pi over 2 pi over 3. So I put z prime equal az plus b, a equal e to the I alpha. It is equal e to the I 2 pi over 3. To change it to algebraic form, I change it to trigonometric form. A equal cosine 2 pi over 3 plus I sine 2 pi over 3. Cosine 2 pi over 3 is minus half. A equal minus half. Sine 2 pi over 3 is I radical 3 over 2. So z prime equal minus half plus I radical 3 over 2z plus b. This is A. B, to calculate B, I can say z omega equals b over 1 minus a. So minus 3 plus 3i equals b. 1 plus half plus minus I radical 3 over 2. Cross multiplying, b equals minus 3 plus I. 1 plus half is 3 over 2. Minus I radical 3 over 2, which is b. Expand, we get b equals minus 9 plus radical 3 over 2 plus I into 3 plus radical 3 over 2. So z prime equal az, missing here z, a, z, here في z, plus b. The last exercise is exercise 16. Determine the nature and the elements of the transformation f defined by first one, z prime equals z minus 1 plus I. Here, since it is a equal 1, we have a translation with translation vector minus 1, 1. Exercise 16. So a equal 1, then f is a translation of vector v of fx minus 1 plus I. Second part, z prime equal radical 2z plus I minus 1. Here a is radical 2. Radical 2 is a real number. So z prime, or f here is a dilation with ratio radical 2. And to find the fx of the center, we say z omega equal b over 1 minus a. Z prime equals radical 2z plus I minus 1. A equal radical 2, which is a real number. So F is a dilation of ratio K equal radical 2. Z omega equals B over 1 minus A equal minus 1 plus I over 1 minus radical 2. We rationalize. So we get 1 plus radical 2 minus 1 plus radical 2I. So center omega of Fx, 1 plus radical 2 minus 1 plus radical 2I. Part 3. Here we have E 2I, 2 pi over 3I. So it is a rotation of angle 2 pi over 3. Now we need to find the Fx of the center. So F is a rotation, F rotation of angle 2 pi over 3 and center omega of Fx. Z omega equals B over 1 minus A. B is 3 plus I over 1 minus A. This is A. I change it to algebraic. First, I change it to trigonometric. Cosine 2 pi over 3 plus I sine 2 pi over 3. Cosine 2 pi over 3 is minus half plus I radical 3 over 2. It will be equal Z omega equal 3 plus I over 3 over 2 minus I radical 3 over 2. This is minus. We can use the calculator. By using the calculator, or first this 2 حطها فوق 6 plus 2i على 3 minus I radical 3. You multiply by the conjugate, or directly you can use your calculator. We get this is the Fx of the center. Finally, Z prime equal minus 5 over 2Z plus 3 plus I. Here A equal minus 5 over 2, which is real. Yani F is a dilation of center minus 5 over 2, and Z omega equals B over 1 minus A. F is a dilation of ratio minus 5 over 2, and center Z omega equals B over 1 minus A. B is 3 plus 2I over 1 plus 5 over 2. See, 3 plus 2I over 7 over 2 equals 6 over 7 plus 4 over 7I. The last exercise, 16. Let F be a dilation defined by this form, Z prime equal U squared Z plus U minus 1, where U is a complex number. Determine the complex form of U if F is a dilation of ratio minus 2. F is a dilation of ratio minus 2. So I put U squared equal minus 2. Then U equal plus or minus radical minus 2. U equal plus or minus radical minus 2. So U equal plus or minus radical 2. I can put it plus or minus radical 2I squared. It is equal plus or minus I radical 2. So don't forget to put plus or minus, plus or minus. This is all about the exercises. This is all about dilation. Tomorrow we'll start with the last chapter in transformation. Okay, see you tomorrow.